Number 7, Juno wrote all the numbers from 100 to 120, inclusive, which means we include the 120 and the 100. What is the sum of all the digits Juno wrote? So the number 100 has a sum of 1. 1 plus 0 is 1. 101 gives us 2. And we can continue that pattern all the way up to 109, which gives us a sum of 10. So 1 plus 10 is 11. 2 plus 9 is 11. 3 plus 8 is 11. I could just keep going, and I have all these pairs of 11, don't I? In fact, I'm going to have 5 pairs of 11. So 11 times 5 gives me 55 for those. Starting with 110, it starts back over again for the pattern. So that has a sum of 2 if I add those digits. 111 has a sum of 3 if I add those digits. All the way until I get to 119, right? It continues that pattern. And that one's going to have a sum of 11. So here it's 2 plus 11, 3 plus 10, 4 plus 9. Those all have a sum of 13. And there's going to be 5 pairs of those. So 13 times 5 is 65. Then my last one is 120. 120 has a sum of 3. So if I just add 65 and 55, I get 120. Plus the 3 is 123. Okay, number 8. This one looks a little tricky. It says we have 4 congruent unshaded squares inside a large square. The 9 shaded regions inside consist of a small square with an area of 1/4. So this square has an area 1/4 of this square. Okay, and then it gives us the area of those triangles, which is nice. So the small ones are going to be 4, and the slightly larger ones are worth 5. Okay, well, whenever they tell me the area of the square, I want to go back to that formula. It's a equals s squared. So let's say that I called this x for that side length of that small square. So that one's going to be a equals x squared for the small square. But then the larger square here has an x and then another x, which makes it 2x, right? So this is 2x, and then this side's 2x because it's a square. And 2x times 2x gives us 4x squared for the area of the bigger one. And that matches, right, with that clue they gave us that it's 1/4. Because if you multiply this by 4, you get this. Now there's a sneaky little thing we can do here. If we look at, I'm going to use a different color here. I'll use green. So if we look at this triangle here and we flip it over, it goes halfway to there. And then flip it again, it's here. And then there's actually a total of 4 of those triangles. If we flip them and rotate them and all that, there's going to be 4 of them that fit inside that square. So that's pretty cool because we know the area of each of them. So if there's 4 of those, 1, 2, 3, 4, that means that area there is going to be worth 5 times 4 or 20. So this is worth 20 for this one, and 20 for this one, and 20 for this one, and 20 for that one. So 20 times 4, that's worth 80 for those squares. And then I already know that this area of that smaller square is 1/4 of it. So I just take 20 divided by 4, and that's worth 5 as well. So 5 for that small square. And then I'm just going to go back to the thing they gave me here in the problem is there's 4 triangles with 5. So 4 times 5 is 20. It says there's 4 with 4. So 4 times 4 is 16. And if I add these numbers, I should have my area. And that's going to be 9, 11, 12, 121.